Good afternoon, everybody. Thank you for joining to our very first pollution prevention webinar series of the 2026. This one is brought to you by the ECU Center for Sustainable Energy and Environmental Engineering. And the title of this webinar is Energy Saving Strategies for Commercial Buildings. Next slide, please.
Yeah, I changed the slide.
So the mission of the Center for Sustainable Energy and Environmental Engineering seeks to provide scholarly applied research and consultancy for sustainable energy development, conservation of natural resources, and the center strives to enhance the public awareness, promote renewable energy technology and natural resources through a focus on research and workforce training. Can you switch to the next slide, please?
Yeah, there is next slide.
So our services include monthly webinars, such as the one that we are hosting right now. We also do workshop and technical training courses. We also can offer cash flow and market analysis, technical engineering and support, and of course, energy, water, and lean assessment. Everything is brought to you by federal grants, and it's really under the pollution prevention section in the center. Can you go to the next slide, please? So this is just like a quick webinar details and participation guidelines. The recording of this presentation is available. This one will be recorded and then shared in our YouTube channel. For the speaker presentations, will be sent via email after the sessions, meaning that you are going to have all the materials. Ask the questions. Please drop your questions in the chat or turn on your microphones during the Q&A session that we're going to have at the end of the meeting. And please, we value your input, so share your feedback to improve this one and our future events. Can you go to the next slide, please?
Yeah, I see the next slide.
So today we are joined by Dr. Moorthy Muthukrishna, PhD, and this is a comprehensive biography of him, but I will just like to add that he obtained his master's and doctorate degrees in electrical engineering for Virginia Tech at the USA. And Dr. Moorthy has worked on several projects in the areas of solar PV, microgrids, electric vehicles, and BEV systems. So he's also working with Waste Reduction Partners, Asheville, as an energy assessor, helping businesses, industries, and institutions to study energy consumption and work towards energy efficiency and conservation. He serves an adjunct faculty in the master's program in applied climate studies in the Warren Wilson College in Nashville Bay area. So, Dr. Mori, thank you for joining us. And from now on, I'll give it to you.
Yeah, thank you so much. Um, Good afternoon, everyone. I see a lot of my colleagues from Waste Reduction Partners, and without their support, I won't be here because I started with Waste Reduction Partners about a year and a half ago, and I learned a lot from many of our senior colleagues and many projects as well. So this particular presentation is based mostly on the work we do with waste reduction partners for various clients. And today I'm going to talk about energy conservation strategies for commercial buildings. And I'm assuming that some of the audience, some members of the audience may not have much background in energy studies, energy audit, energy conservation, and so on. So I have some extra slides that will give the background information. Again, my colleagues from Waste Reduction Partners, they are experts in that, so they don't have to go through that. But for the sake of others, I will quickly go through some of the background information as well. So these are the topics that we are going to go through today. Energy audit, and you might ask why we need to go through energy audit. Energy audit is probably the starting point for the energy conservation measures. So I'll quickly go through the energy audit. Again, as Pablo mentioned, I'm teaching this as a full course for Warren Wilson College students, and that lasts about 7 whole weeks, 2 hours per week, and then we do a lot of projects as well. And so this is the kind of condensed version of that particular course material. Then we'll go through the energy conservation strategies in detail. We'll go through lighting, HVAC, building envelope, water heating, and solar PV and microgrids. Again, I haven't included all the energy conservation measures. I have included only the major ones because of the time limitation. And at the bottom of every slide, I have provided some links to additional material. So offline, you might want to go through those links and learn more about each of these topics, get more details about these. So where do we need energy audit? And we'll look at the energy audit levels, energy audit process and results and so on. Again, I'm not planning to go through this in detail because there's lots and lots of information behind this. So I'm just quickly go through what is energy audit and how do we analyze the data, how do we produce the report, and then what are the contents of the reports and so on. So why do we do energy audit? Energy audit is mainly to identify energy use. Where do we use energy? What kind of equipment in the building or the particular campus use energy? And also the cost of operating a building or maybe the whole campus, multiple buildings on a campus. And we also try to identify modifications that will reduce the energy cost and energy use. That's very important. And that's where the energy conservation measures come into picture. And also we provide information as a form of report and recommendations to the building owners. The building owners could be a government or a particular industry organization or university and so on, maybe individuals as well. So there are three levels of energy audit. One is energy level 1, level 2, and level 3. Again, these are all uh, standardized by ASHRAE and other organizations. The level 1 is baseline analysis. For example, we are doing the energy study, energy audit for the first time. That's what we will do, level 1. So it's also called walkthrough analysis. Normally, we interview the personnel in the particular organization or particular building, and also we review the energy usage in that particular building or maybe multiple buildings, and then produce a report. And level 2 energy audit is a little bit more detailed. And whenever we do level 2, we do level 1, all the things in level 1, and also level 2. So this is a little bit more detailed. When we interview the personnel in the particular building or particular client for the particular client, it will be more in-depth interview and ask them for their insights, problems, their goals, and so on. And also analysis will be more rigorous. And again, the ASHRAE standards that we are going to see in the next couple of slides, they give very detailed information on how do we do the energy audit and how to prepare a report and so on. What are the contents of the report and so on. And level 3 is more for after we do level 2, implement energy conservation measures. And we want to see how it has improved or how it has reduced the energy use. So for that, we can set up some sub-metering for monitoring individual systems or subsystems such as HVAC and see whether energy conservation measures that were implemented, they have improved the overall energy use. And again, there is a lot of engineering analysis and also to justify capital investments for certain energy improvement projects. So these are the two standards that we are using. One is energy ASHRAE standard 100, 2024. Again, this 2024 indicates the year in which it was the most recent version. And this is for energy and emissions building performance standard. This gives the standards for existing buildings, not for new buildings. And there are about 50 different commercial, industrial, institutional buildings, and about 5 different residential buildings. And the next standard we use is ASHRAE 211. I could get only the older version. Probably there is a new version. And this is the energy audit procedure itself. So what do we do during the process? We collect and analyze the energy use, and normally it's for about 12 months, and study the building characteristics. For example, the building envelope, roof, windows, and when the building is open, how many people work in the building, the square footage, and so on. And next one is what are the different potential modifications? For example, improve the roof, or maybe change the windows from single pane to double pane, maybe put some curtains, shading, and so on, and how that will reduce the energy use and cost. And the next one is can also do engineering and economic analysis. Economic analysis is how much money you have to spend upfront and what is the return of investment for the potential modifications. And also, as a part of the report, we produce a rank ordered list of modifications, which has the highest impact and which has the lowest return of investment. And eventually, ultimately, we have to prepare a report and submit to the client. The results, I have listed only the most important results: energy use intensity, that is, energy used per square foot per year. And this is normally in kilo BTU, KBTU. And the energy cost index is the dollars, energy use in dollars per square foot per um, year. And the reason why we do that is we can compare the UI and ECI against the same type of buildings in the same climate zone. Again, I'm not able to go through the climate zone right now, but normally what happens is there is a climate zone map as far as ASHRAE publishes. So we are in North Carolina, most of North Carolina is in climate zone 3A, that is humid and warm. And so we can compare the same type of building. For example, if it's a university building, we compare against other university buildings in the same climate zone. And finally, we can recommend energy conservation measures. So these are some of the graphs and charts that we produce as a part of the report. And as you can see, this is 12-month data of monthly energy costs, both gas and electricity in this particular building, and then separate out electricity usage and cost, natural usage and natural gas usage and cost. And this is the breakdown of where the energy is being used. For example, HVAC, lighting, and so on. So this is the chart that we would refer to when we compare the energy use intensity, that's the EUI. I highlighted mixed use office. And as you can see here, for zone 3A, it has to be 33 kBTU per square foot per year. And if the building that we are doing energy audit on, it comes over that, then we need to do some improvement. So we got to identify some of the energy conservation measures, do some improvement, and implement those improvements, come back after 6 months, 1 year, do energy audit and see whether it made any improvements. So that's where I just reproduced only one page. There are about 3 pages containing the different buildings, energy use intensity for different buildings. So now we'll go through the energy conservation measures. And again, we'll come back to any questions at the end of this presentation. So there are several things that we can do to improve the energy use. That means reduce the energy use. That way we can reduce the energy cost. So first one is lighting. Again, I'll go through that in some detail as the time permits. Then HVAC, heating, ventilation, and air conditioning, building envelope, water heating. Again, water heating is not that much of energy use, but still we'll go through that. And then finally, I will conclude the presentation with some recommendations on solar PV and microgrids. So this is from year 2024, how the commercial buildings um, distribution is. So the graph on the left side, the column on the left side, it shows the square footage of different types of buildings. The bottommost is 20% warehouse, 19% offices, 17% service and mercantile, 14% education, and so on. And on the right side, we'll see the energy use, total energy use for these categories of buildings. So warehouse uses about 10% of the total energy. Offices use about 19%, which is the same as the square footage. The service and mercantile, they use about 17%, education 14%, and so on. So this is just to give us an idea about how much square footage of commercial space is there, how much energy is being used. Again, I put a note over here for those who are not familiar. Quad BTU is 10 to the power 15 British thermal units. So this is another breakdown of where the energy is being used for commercial buildings. And again, space heating, ventilation, and cooling, it comes to about 33%. Next is lighting, refrigeration, computing, and so on. And the other 42%, I know you might ask why it is so high. So these are all for escalators, elevators, and all those things. So some of the facts. The total energy used for commercial buildings is about 17% of the US total, and that includes residential, industrial, commercial, and everything else. And it has increased 64% from 1980. Total money spent is about $241 billion in year 2024. It's a large lot of money. And again, HVAC that uses about 33%, lighting uses about 8%. And building construction only about 10 to 20% during the construction. Remaining 80 to 90% is during the building's life cycle. Maybe the building is good for about 20 years, 30 years, maybe 40 years, depending on the type of the building. So 80 to 90% of the energy is being consumed during the life cycle of the building. So now we'll come to the point where we can discuss more about the energy conservation measures. And again, this will be referred to energy efficiency measures in the ASHRAE standards. And some people call it as ECM, energy conservation measure. It will also be written as energy savings measure. All these mean the same thing. So as a part of the energy audit report or energy assessment report, we'll give recommendations about what to do to improve the lighting. That means reduce the energy use for lighting, HVAC, and other appliances, other areas of energy use. So lighting uses about 8%. And we'll start with the no cost or low cost measures. So no cost, you don't have to spend any money, or maybe you have to spend a little bit to save some energy. So simply turn off the lights when they are not in use. So most of the time when we go through the buildings, visit the buildings, or even in the university buildings, people just leave the lights on in their offices. So we can just turn off the lights when it is not in use. And we also recommend installing occupancy or motion sensors. These cost only very little, maybe $20 to $40. I checked the price last week. It's only about $20 each of this motion sensor. So instead of the switch, we can just plug in these sensors and they will take care of that. This is very useful for restrooms, conference rooms, and other places where the occupancy is not all the time. In the offices, personal offices, people stay there all the time, but in other places, people don't. So it's a good idea to use this. And also there are some roof mounted sensors like what you see at the bottom of the slide. And that can be installed in a conference room or it can be installed in a corridor where it senses the presence of people and keep the lights on for a few seconds or a few minutes. It can be adjusted. And also we can schedule the lighting using the building automation system. For example, the building is open from 8 a.m. to 5 p.m. So we can keep the lights on. And after that, we can turn off most of the lights and keep only the emergency lights and some um, lights that are really required. In some cases, we have to spend some money in order to get some energy savings. Again, incandescent bulbs, the filament bulbs, they are not, I mean, most of the places we have visited, they have already upgraded to either CFL or LED. So we recommend that upgrade everything to LED. And similarly, the fluorescent tubes can be upgraded to LED tubes. Again, the LED tubes are available. So you can just drop in replacement or you can replace the whole fixture as well. So the fixture is going to cost a little bit more money, but it is worth over the long run. So what are the advantages? We can save anywhere from 50 to 75% energy savings because of converting to LED. And these LEDs last 10 to 15% 15 times longer, sorry, 10 to 15 times longer. That means it's low maintenance. You don't have to go up the ladder and change the bulbs and so on. And the fluorescent lamps normally contain mercury inside. So disposing that is kind of difficult. And also it is environmentally not good. So as far as LEDs are concerned, we can easily dispose. I even checked with the local recycling people and they said you just put it in the trash. And I don't know how good it is. Anyway, so some statistics, if you convert everything, all the lighting into LEDs by 2035, that's about 10 years from now, we can save about 570 terawatt hours of energy. And that's equivalent to 1000 1000 megawatt power plants. So you don't have to install or construct 92 power plants. So that's a large number. The second and probably the most important energy conservation measure is HVAC because HVAC consumes about 32% of energy overall. So again, my colleagues from waste reduction partners and academic colleagues from ECU, they will be very familiar with this. And for those who are not familiar with this, I'm just quickly going to go through what are the different types of HVAC, and then we'll go into the energy saving measures for HVAC. So what is HVAC? Heating, ventilation, and air conditioning. So that is abbreviated as HVAC, and some people call it as HVAC. And using HVAC systems, we control the temperature inside the particular space. They call it conditioned space, humidity, as well as the air quality. During summer, we need to cool. During winter, we have to heat, depending on particular location. And heating can be natural gas or electric. So what is inside a HVAC unit? What is in a HVAC unit? And again, this is a room. And in the room, we need to supply fresh air. So the fresh air comes through an air handling unit. It's called AHU. Inside the air handling unit, you have a damper. Damper controls the airflow. And then there will be a heater, fan for pushing the air for circulation, and also humidifier. In some cases, you will have humidifier as well. So, and also heater. The heater could be again natural gas or electric. So for cooling, we'll have an external unit. There is a chiller outside. So the chiller supplies cold water, and the air is cooled, and the air is supplied to the room, and the return air is going through another duct and that comes back here to the AHU. In the next slide, in this slide, I've got a more detailed diagram of AHU as well as the air conditioning unit. And again, already I mentioned that the AHU has fresh air intake and there'll be dampers. I don't think they have shown the dampers here. Dampers are basically like valves that regulate the airflow. And then we have filter, heater, and then we'll have fan to push the air to the room. So some of the hatchback system types: single split system, multi split system, VRF, that is a variable refrigerant flow system. It's also called variable refrigerant volume system, and a package system and heat pump systems. Again, I have got each slide, I mean, one slide for each of these. So single split system, this is very common. You must have seen it in your house as well. So normally there'll be an external unit or outdoor unit, as you can see here on the right side bottom. So the external unit is outdoor unit is called a condenser, and then it actually transfers the heat from inside the room to the outdoors, that is the environment, and then it sends the refrigerant back into the indoor unit, and the indoor unit that absorbs the heat from inside the room, and then again sends the refrigerant back to the outdoor unit. And again, because of the lack of time, I'm not going into the details of each of these, and there's lots and lot more information into that. And indoor unit will contain a fan to circulate air, and also filter unit and a heater. The heater could be natural gas or electric. But this is good for small buildings. It's not good for large buildings. The large buildings we have to use more complex systems. And again, in my experience, going to a lot of different clients, this we have seen for small buildings, installed in small buildings, maybe about 2,000 square feet or so, or maybe even less. And the next system that we are going to see, this is called a multi-split system. There'll be one single outdoor unit. And again, this is just a representation. The outdoor unit would be much bigger than that. And the indoor unit, there are multiple indoor units. These are all um, installed in different rooms where we need to have more precise control of the temperature and the airflow. So as you can see here, there are 5 different indoor units connected to one single outdoor unit. And there are 5 different controls, thermostats. We call it, I mean, it's a control system, but normally people call it as thermostats. So this is called a multi-split system. This is for slightly larger buildings. And we can save more energy by this variable refrigerant flow system. So what it means is that it changes the refrigerant flow based on the requirement. So by that, we can reduce the energy consumption by 40 to 50%. It's 40 to 50% more efficient. The next one is called a package system. The package system, it's normally one single unit. It looks like a big box, as you can see here. And this is either located on top of the roof or maybe on the ground somewhere outside. So this contains both the cooling and heating. And they say that it's easy to install when compared to the multi-split system and so on. And everything is contained in this single unit, and it is reduced noise and so on. And again, it all depends on the particular unit, I mean, particular building. So in some cases, the roof will not be able to hold such a heavy weight. So you won't be able to install this on the roof. So you have to install it on the ground. So heat pump systems are becoming more common now because heat pump is not heating using natural gas or electricity. Instead, it is just transferring the heat from one location to another location. For example, if you want to cool, so it is just transferring the heat or absorbs the heat from indoors and then throws it outdoors. And that's the normal air conditioning. And it can also operate in reverse. So when we want to heat, we can absorb the heat from outdoors and then heat the indoors. So in addition to that, we can use geothermal to heat. And if the temperature goes too low, we can use gas and electricity to heat, to provide more heat. So it has got very high efficiency. These are becoming very common, and we don't have to have boilers and cooling towers and so on. So that way we can save lots and lots of energy. Again, as I mentioned earlier, I have provided links below at bottom of each slide. So you can just click on that, go to that particular location, website, learn more about these. So now we will come to energy conservation measures. So what can we do to reduce energy consumption of the HVAC systems? So first we'll go through the no cost and low cost. That means we don't have to spend any money or we have to spend some minimum amount. All we have to do is just change the temperature. For example, during the winter, people want to set it at 70 degrees, maybe 72 degrees. It might be too high. So we can reduce the temperature to 68 degrees when the building is occupied. And when it is unoccupied, for example, during the evening hours, nighttime, and so on, nobody's there in the building. So where do we have to heat it to 68? So reduce to 65, even below that. Again, it all depends on the particular client, particular building, but this is what we recommend. That way, for every 1 degree Fahrenheit change in the temperature, it leads to about 1 to 3% of the energy savings. So, which is a pretty good savings. Now, all you have to do is just reduce the temperature. And during the summer, instead of cooling down to, let's say, 70 degrees or maybe 68 degrees, I've seen some places cool down to about 65. So, if it is not required, increase the temperature to maybe 72, 73, 74, and so on. Again, it's up to your comfort level, but it's a good idea to increase the temperature. And if it's not occupied, for example, during the night hours and when there is nobody around during the weekends, increase the temperature even higher. And other thing that can be done, again, most of the modern buildings, they have building automation system. So building automation systems can be programmed so that it will automatically set the temperature and it will even monitor the zones, each zone, and individually control the temperatures for each zone. So make use of that. Periodic maintenance, we also recommend periodic maintenance, that is changing the filters. So for example, for the houses, residences, we change the filter every three months or so, or as and when it is required. Whereas in the commercial buildings, they might change the filters every month or every 2 months, depending on the usage. And also the clean the coils, condenser coils and evaporator coils. It's a good idea to clean so that the efficiency is maintained. All right. So now let's see, we have to spend some money to do some more energy conservation measures. And actually, standards, they call it capital expense energy conservation measures or EEMs, energy efficiency measures. So normally the HVAC units, they last for about 15 to 20 years, maybe, yeah, 15 to 20 years. So when you replace, you don't say anything, the HVAC contractor, they are going to say that they are going to replace with, they won't even say, but they'll replace it with standard efficiency system. Standard efficiency system has 85% efficiency. Whereas the same model, again, if you go through some of these companies' products, Carrier, Train, and Lennox, and so on, you will find that for the same model, they have different efficiency, 85%, 90%, 95 to 98%. So it's a good idea to replace the older system with high efficiency system if it is possible. Again, you don't have to replace the existing system when it is end of life. When you want to replace, better to replace with high efficiency system. And also look at replacing with heat pump system. As we mentioned earlier, heat pump heat pump all it does is transfers the heat. It doesn't generate heat using the electricity. Instead, it just transfers the heat. So it's very highly efficient, reduce the electricity use by about 50%. Some of the other solutions I have listed here, and again, we don't have time to go through these. And there are heat recovery systems available, and these systems they recover heat from the chillers, recover the heat from you know, yeah chillers and then exhausts and so on. And we can use geothermal energy for water heating, space heating, and cooling. So this is done in UNC Asheville campus and also the Wake Tech campus here. The, they call it Wake Tech Eastern Campus. And also we can recycle water from the cooling towers. For example, the cooling towers, they keep cycling the water gets lost or water gets just dumped. So instead of doing that, we can get the water, capture the water, and then use it for other purposes such as irrigation and so on. In older buildings, again, these are like 50-year-old, 100-year-old building. Normally, they circulate steam to heat the space, room heater. They will have the radiators and use that steam. Instead of that, we can use hot water. But again, the conversion will take a lot of money, but that is being done. The next one is building envelope. The building envelope is basically the walls, floors, roof, and windows and doors. So again, I have a couple of slides coming up, and there are seminars, webinars organized by Department of Energy, and it's called the um, Better Building Program. So I think it's every week or every other week. They do have webinars that talk more about how to improve the building envelope, so on. So we got to properly insulate the walls. Again, normally the walls and windows, they follow the code, but even then it's not energy efficient. And I have in the next slide what happens when you follow the code, how much energy it's going to, I mean, how much heat it's going to lose. So we can, instead of single pane windows, I don't see any single pane windows now. So mostly it's double pane. So if you upgrade the windows, go to triple glaze windows. And one of the webinars, they were mentioning that we can even put additional windows, either externally or internally, in order to save energy. We can also do tinting, so tint the windows to reduce the light coming in. And also we can use curtains, blinds for the windows. Doors, it's a good idea to insulate. For the new buildings, when we design the new buildings, it's a good idea to proper orientation. For example, if it is south facing, and then put windows on the south and the west so that it can capture heat and light. So this is the slide that I got from one of the webinars. And windows, this is just an example of windows. Windows occupy about 12% of the area of the envelope. The remaining 88% occupied by walls, roof, and floor. And windows cause about 53% of the heat loss, which is huge. So if you just follow the code for the windows, we are going to lose about 53%. And instead, if it's R5, it's 38%. I don't know what R5 for the windows are, but if you improve the windows, you can reduce a lot of heat loss. Um, yeah. So this is another slide that I got from the Better Buildings webinar. And again, as you can see here, single pane windows, this whole space, it's not comfortable in the sense it is too hot or too cold. When you have triple pane windows, the whole room has uniform temperature. So it is pretty comfortable. Up to 70% of the heat is kept inside during summer. I'm sorry, outside during summer and inside during winter when you use triple pane windows. So next is we have about 10 minutes. So I'll quickly go through the remaining slides. So water heaters, they don't consume so much energy as compared to HVAC and lighting, but it is still significant, 3%. And as you know, we use water for cooking, cleaning, and washing clothes, restrooms, showers, and so on. Normally, what we have seen is they use electricity or natural gas. Natural gas is more common when compared to electricity. And what do we do to improve the energy efficiency of water heaters? We can adjust the temperatures based on the season. For example, during the summer, we don't have to have it so hot. So we can reduce the temperature. During the winter, we can increase the temperature. And a lot of people, they don't do the maintenance, periodic maintenance of water heaters. So it's a good idea to flush. That is, there might be some sediment inside the water heater, and that reduces the heating efficiency. So it's a good idea to flush it and clean it at least once a year. Optimization of capacities. You don't have to have a big water heater for a small room or small building. So try to optimize. And that way we can save some energy. And there are high efficiency water heaters available now, including the heat pump water heaters, which save about 70 to 80% of the energy. And also we can use the point of use water heaters. That means just install it under the sink instead of having a centralized water heater. From that, we have to carry the hot water all the way from wherever the water heater is to the sinks or the showers. All right. So this is the last topic that we are going to talk about today. And we also recommend using the solar PV. Again, this slide is meant for people who are not familiar with that. So basically, the solar energy is converted into electricity, directly converted into electricity using the solar cells. And many cells are put together in series to form a panel. And this is also called module, solar module. So the module, several modules are connected together in order to capture solar energy. And then that is connected to the building or maybe even a grid. So this is a very simple schematic diagram of how the solar panels are connected. Normally, the solar panels are connected to the customer distribution board, and there will be a separate switch gear. That means a switch to connect or disconnect. This could be even automatic. And then we have loads over here. The loads could be lighting, HVAC, water heaters, and other appliances. And then we have a local diesel or gas generator set. And this set supplies electricity when the grid power goes down or even the solar power goes down, which is normally not the case. And the excess power is being exported to the grid when there is excess power during the daytime. For example, the solar power generates more than what we can consume. And also the same lines, same cables, they bring power from the grid through the net meter to the customer's main board, and then the loads. So this net meter can run both ways. So when the power is getting, it also keeps track of power that is imported from grid and also exported to grid. But again, it all depends on the utility company. This policy keeps changing, and nevertheless, these net meters are available. So the next step is microgrid. So you might ask, what is the difference between microgrid and just the solar power? So solar power, it just gets connected to the main board, and whenever there is solar, it gets connected, and then we will have an inverter here, and the inverters are becoming more and more intelligent, smart, and these microgrids are even smarter than that. There is a microgrid controller. And as you can see here, microgrid controller connects the load. And then we have a generator, we have an EV, and then renewable energy sources like solar, wind, if possible. And also it's connected to the grid. So the good thing about microgrid controller is it keeps track of when the electricity is cheap. So based on that, it can get the electricity from the grid, store it in the um, battery, and then use it when the electricity is more expensive, that is during the peak hours, peak demand hours. So that way we can reduce the cost. And also when the solar is generating more electricity than what we can consume, it gets stored in the battery, and then we can use that during the peak demand hours or when there is a power outage, grid outage. Again, these microgrids are becoming more and more popular, and I believe the US military is using on all their bases these microgrids. So what I listed several advantages. We won't go through that in detail. So basically, you are in control of the energy you generate locally. So it's more efficient, more reliable, and also it reduces the load on the grid. So what we have seen so far, we looked at energy audit. What are the different levels of energy audit? And then we looked at energy conservation strategies. These are also called energy conservation measures, energy efficiency measures, energy saving measures, and all those things all mean the same thing. We looked at how we can save energy by implementing some of these measures for lighting and HVAC, for example, going to heat pumps or using the building automation system, improving the building envelope, such as changing the windows to double pane or triple pane, and also improving the insulation and water heating. Again, it's not as much, doesn't have as much impact as HVAC or lighting, but still it has got considerable energy saving. And we also looked at solar PV and microgrids. We have about 2 minutes time. And these are the references that I use. And again, I have a whole list of references. If you are interested in, I can pass on to the organizers. So they will put it in their website. And these are some of the organizations that have lots of information. For example, Department of Energy has a lot of information, wealth of information on all these topics. And Energy Audit, ASHRAE has quite a lot of information and also resources. And for green and efficient, energy efficient buildings, there is US Green Building Council, PHI US, that's called FIRES, and the Better Building Solution. This is again under Department of Energy. So with that, we'll come to the question and answer session. And again, um, I may or may not be able to answer all your questions. I'll try to answer all your questions. If you are not able to answer, you can send me an email or, yeah, so send me an email and I will try to answer over email.
Well, thank you, Dr. Morty, for the useful information shared in this webinar. Now we are in the Q and answer session. So we have two questions dropped in the boxes. So the first one is, do you have any information or statistics on how BAS controls management helps save energy and promote sustainability? I think BAS is building automation
Building
systems,
on,
so that'll
yeah,
be.
yeah, building automation system. We see building automation system in larger buildings. For residences, you must have seen smart thermostats, right? Smart thermostats is they are programmable. I mean, the simplest terms, they are programmable. So you can program when you have to increase the temperature. For example, during the daytime, you want to increase the temperature to, for example, it is winter. So during the daytime, you want to increase it to, let's say, 70 degrees. And during the nighttime, when you are sleeping, you don't have to have 70 degrees. Instead, you can reduce it to, let's say, 68, 67. So this can be programmed. I've seen some simple thermostats, smart thermostats you can program by day for Monday to Wednesday, Monday to, let's say, Friday, you are not home during the daytime. And you don't have to keep the temperature really high. So you can reduce the temperature, let's say 65 instead of 70. And then once you come home, you can increase the temperature. So on a building automation system, it is done on a larger scale. So you have several zones, several rooms, and each room will might have a different function. Some of them might be occupied throughout the day or maybe during the particular shift, and some of them might be a manufacturing floor and warehouse and so on. So building automation system, each of these zones can be individually controlled. Temperature can be controlled, also the airflow, when the lighting can be controlled. Did I answer the question?
Hopefully, yes. Thank you for thank you for your answer, Dr. Morty. Now we have another one. It says like, please discuss how to reconcile temperature set points with personal comfort levels. If people are uncomfortable, they will not be as productive.
Yeah, that's always a big big sticking point. Wherever we go, people are saying that they have some resistance or some kind of reluctance from the people who occupy that particular location, particular area. And that's always going to be the case, but you have to take their comfort into consideration because they have to be there for 8 hours a day, maybe more during the work hours. So normally what we have seen is that they give about plus or minus 2 degrees local adjustment. Otherwise, it is set through the building automation system. So people who are locally, and they can adjust plus or minus 2 degrees, not more than that. So that way they have a satisfaction of adjusting. And another thing that we have noticed is um, some people use personal heaters, room heaters, and that's kind of dangerous. One, it consumes a lot of power, which is not controlled. And the second thing is it's a fire hazard. For example, they leave the heater on and the heater tips over and it can catch fire. The surrounding papers, whatever you have around that, if it catch fire, it could cause the fire for the whole building. So in that case, it's even worse. So many companies, what we have seen is that we even recommend that people don't use personal heaters or even personal coffee machines, toasters, ovens, and so on. Yeah. So that's always to come to the point. That's always a point of discussion wherever we go. And again, whoever is the maintenance people or facilities people, they have to work with the people who are working over there, the occupants of the building, to come to a kind of agreement of what temperature is agreeable for them.
Thank you, Dr. Morty. I don't see any more questions in there, but I maybe can ask you one since you've been helping with a lot of the energy audits, and then we here at DCU also like do some energy assessment for companies. Many buildings continue to operate as is because the systems still work, but you have like any insights of how can we shift the mindset from it works to it works efficiently in a company?
Yeah, most of the time, as you might have seen on our report, again, there's a lot of my colleagues, several of my colleagues from waste reduction partners, they are here. They have got a lot more experience than what I have on the energy audit, energy um, saving measures, recommendations, and so on. And they must have seen many buildings. So the main thing is the capital expenses, right? So some private organizations, private companies, they will have a lot of money to spend. So they wouldn't mind upgrading the systems to a newer system, more efficient system. But universities, they are dependent on the government funding. So, as you might have seen, some of the school districts, they had to close their schools for the lack of HVAC system. HVAC system go bad, they're not fixed, so they have to let the kids go home for a day or two. And so the thing is that these are very capital intensive. There's a lot of money that we have to spend, and private organizations, they look at how much money, and how much is the return on investment, ROI as they call it. They spend, let's say, $1,000. How many years before they can get the whole money back? Maybe it's 5 years, 10 years. Normally, it's a question of, 5 years is considered to be a good number, right?
Mhm.
And in some cases, like universities, that may not be possible because of the capital is not available. We are dependent on the government. So I faced the same issue when I was in UNC Asheville. A lot of our projects, they were not implemented because they don't have money.
Yes, thank
And
you for answering that final question. I think, yeah, I don't see any more questions in there. So if you can just like go to the next slide.
yeah,
So yeah, this concludes our webinar for today. Thanks everybody for joining us. Eh, as part of our pollution prevention webinar series, we have another one coming on February, and that one is called Design on Manufacturing Systems for Optimal Material Handling. You can see there is more related to like the supply chain and logistics. You can register. You have like the flyer in there, and we also like include the QR code to where you can find information about all of our future events, our services, and so on. And can you just go to the next slide and the final one?
yeah,
Okay, so once more, we want to say thank you everybody for joining us. Hopefully, we will see you in the next webinar in February. And yes, please follow us in our social media and stay active with our events. In LinkedIn, we are as ECU Center for Sustainable Energy and Environmental Engineering. And in Instagram, we are as at ecu.csg3. Please check again the QR code and keep in post with all our future webinars and activities. Thank you for joining us today.